Somewhere beneath the surface of the open ocean, something is beating. Slowly, deliberately. A pulse so powerful, it travels through an entire body longer than a passenger jet, pushing rivers of blood through arteries wide enough for a human to crawl inside. For a few seconds, it stops. And in that silence, an animal the size of a building drifts between life and death. The beat returns. This is not a machine. This is not a myth. This is the living heart of the blue whale. The blue whale, the largest animal to have ever lived, is not simply big. It exists at the very edge of what biology should allow. Stretching over 30 meters in length and weighing as much as 180 tons, this ocean giant defies almost every expectation we have about life. But hidden within its immense body is something even more extraordinary, something that challenges our understanding of physics, biology, and survival itself. Its heart, a single organ, weighing as much as a small car. And yet, despite its size, the true mystery lies not in how big it is, but in how it works. In the cold, dark depths of the ocean, where sunlight fades into blackness, the blue whale descends. With each dive, it enters a world of crushing pressure and dwindling oxygen. For most mammals, this would be a death sentence within minutes. But the blue whale is not most mammals. As it sinks deeper, something remarkable begins to happen inside its chest. Does heart slows? Drastically. From a steady rhythm at the surface to an almost unthinkable crawl. At extreme depths, the blue whale's heart can drop to just 2 beats per minute. Each beat becomes an event. A massive surge of blood pushed through a body the size of a submarine, followed by long, haunting pauses. And in those pauses, time itself seems to stretch. But why would the largest animal on Earth risk slowing its heart to such dangerous extremes? The answer lies in a delicate balance between oxygen and survival. Unlike humans who rely on constant breathing, the blue whale must carry its oxygen supply with it when it dives. Every molecule becomes precious. So the whale does something astonishing. It shuts down everything it doesn't immediately need. Blood flow is redirected away from less critical tissues. Muscles switch to energy-saving modes. And the heart becomes a master of restraint. Each beat is calculated. Each pulse, deliberate. It is not just pumping blood, it is rationing life. But here is where the story takes a darker turn. Because slowing the heart is only half the equation. When the blue whale resurfaces, everything changes. After minutes, sometimes over an hour, beneath the ocean, the whale begins its ascent. The pressure eases. Light returns. Oxygen is within reach. And as the whale breaks the surface, exhaling a towering plume into the sky, its body shifts gears in an instant. Its heart surges. From just a few beats per minute, it accelerates to over 30 beats per minute. For a creature of this size, that is astonishingly fast. Blood floods back into the tissues. Oxygen rushes through arteries. Systems that were nearly dormant roar back to life. It is a biological explosion of activity. But this transition is not without risk. Because pushing blood through a body this large, this quickly, creates forces that push the limits of what tissues can endure. The whale's arteries must stretch and recoil like massive elastic tubes, absorbing the pressure of each powerful beat. Its heart valves must withstand immense stress, opening and closing with perfect timing. Any failure, even for a moment, could be catastrophic. And yet it works perfectly, again and again, day after day. For decades, scientists have only recently begun to understand just how extreme this system truly is. In one groundbreaking study, researchers managed to attach a specialized sensor to a free-swimming blue whale, something once thought nearly impossible. What they discovered shocked the scientific community. The whale's heart operates across a range so vast, it may represent the absolute limits of mammalian biology. At its slowest, it flirts with the edge of cardiac arrest. At its fastest, it pushes the maximum rate at which such a massive heart can physically function. There is no room for error, no margin for miscalculation. The blue whale lives on a razor's edge, where one beat too slow or too fast could mean the difference between life and death. But the heart is only part of the story. Because to understand its true power, we must look at what it supports. Despite its terrifying size, the blue whale feeds on some of the smallest creatures in the ocean. Tiny, shrimp-like animals that swarm in vast clouds. To sustain itself, a single blue whale must consume up to 4 tons of krill every day. That's millions of individual prey, swallowed in enormous gulps. And here, the heart plays another critical role. When the whale lunges forward to feed, it opens its mouth wide, engulfing a volume of water larger than its own body. This sudden expansion requires immense energy. Muscle strain. Blood demand spikes. Oxygen is burned at a staggering rate. And in that moment, the heart must deliver. It must pump enough oxygen-rich blood to fuel one of the most extreme feeding behaviors in the animal kingdom, all while maintaining stability in a body already operating at its limits. It is a paradox. The largest predator on Earth, sustained by the smallest prey, powered by a heart that must constantly balance between conservation and explosion. But how did such a system evolve? How did an animal reach this scale, without collapsing under its own biological demands? The answer lies buried deep in time. Millions of years ago, the ancestors of the blue whale were not giants. They were smaller, land-dwelling mammals, walking on 4 legs. Over time, they returned to the ocean. Their bodies transformed. Limbs became flippers. Nostrils shifted into blowholes. And slowly, they grew. Larger bodies allowed for longer migrations, greater energy storage, and more efficient travel through the vast oceans. But with size came new challenges. Gravity still pulled on their blood. Oxygen still needed to reach every cell. The heart had to evolve. Not just to grow bigger, but to become smarter, more efficient, more adaptable. And so, over millions of years, the blue whale's heart became a masterpiece of evolutionary engineering. A pump capable of scaling its output across extremes. A system designed not for comfort, but for survival at the very edge of possibility. Yet even now, there are questions scientists cannot answer. Mysteries that linger in the depths. How does the whale's heart avoid damage from such extreme fluctuations in pressure? How do its cells survive repeated cycles of low oxygen and rapid reoxygenation, conditions that would cause severe injury in humans? And perhaps most unsettling of all, is there a limit? Because the blue whale may already be approaching the maximum size that a heart can support. Some researchers believe that if whales were any larger, their circulatory systems simply wouldn't function. The heart could not pump efficiently enough. The blood could not reach distant tissues in time. Life, at that scale, would become impossible. Which raises a haunting possibility. The blue whale is not just the largest animal alive. It may be the largest animal that can ever exist. A biological ceiling. A final boundary. And at the center of that boundary, beating slowly in the darkness of the ocean, is a heart that must never fail. But even this incredible system is not invincible. Because beyond the natural limits of biology, a new threat has emerged. One that does not come from evolution or the deep sea, but from the surface, from us. And as we will discover, the blue whale's greatest strength, its immense, powerful heartbeat, may also be its greatest vulnerability. There is a moment, just after the blue whale exhales. A towering column of mist rises into the air, visible for kilometers. To us, it is a spectacle. To the whale, it is survival. Because every breath it takes must refill a system that is constantly walking the edge of collapse. And now, for the first time in its evolutionary history, that system is being pushed beyond its limits. The ocean is no longer silent. It hums. Low-frequency vibrations, generated by cargo ships, industrial engines, and distant drilling, spread across entire ocean basins. Sound travels differently underwater. Faster, farther, deeper. And the blue whale is built to hear it all. These giants communicate using some of the lowest frequency calls in the animal kingdom. Deep, resonant pulses that can travel hundreds, even thousands of kilometers. Their entire world is mapped in sound. But now that world is crowded. Artificial noise overlaps with their calls, masking signals, distorting communication, and forcing whales to adapt in ways we are only beginning to understand. And inside their bodies, something subtle begins to change. When a blue whale is exposed to constant noise, its behavior shifts. It dives differently. It surfaces unpredictably. It may even abandon feeding grounds. But the most profound changes are invisible, because stress, in a body this large, does not announce itself loudly. It whispers through the heart. In many mammals, stress triggers an increase in heart rate. A surge of hormones floods the bloodstream, preparing the body for action. But for the blue whale, this response is dangerous. Its heart already operates at the edge of its physical capacity. There is very little room to accelerate further. And so, repeated disturbances, ship noise, sonar pulses, sudden intrusions, may force the whale into a constant state of physiological strain. A system designed for balance, pushed toward instability. But sound is only the beginning. Far above the depths, ships carve invisible highways across the ocean. Massive steel hulls move with unstoppable momentum. To us, they are symbols of global connection. To a blue whale, they can be fatal. Collisions between ships and blue whales are among the leading causes of death for these animals. And the reason lies, once again, in the rhythm of the heart. Remember how the whale dives. How its heart slows to just a few beats per minute. How its awareness shifts inward, conserving energy, focusing on survival. In that state, reaction time is reduced. The whale becomes less responsive to sudden changes in its environment. And when it rises to breathe, it often does so along predictable paths. Paths that now intersect with human activity. A ship traveling at high speed does not have time to stop. A whale surfacing from the depths does not have time to react. And in that brief, tragic overlap, the consequences are devastating. But even when whales avoid direct collisions, the effects of human presence linger. Fishing lines stretch across the ocean like invisible traps. Some whales become entangled. At first, it may seem minor, a rope wrapped around a fin, a line dragging behind. But over time, the impact grows. Dragging gear through the water requires energy. Energy that must be supplied by the body. And once again, the burden falls on the heart. The whale must work harder to swim. Its muscles demand more oxygen. Its heart must beat faster, more frequently, pushing blood through a system already stretched to its limits. Exhaustion sets in. The whale weakens. And in many cases, it does not survive. There is a cruel irony here. The very adaptations that allowed the blue whale to become the largest animal on Earth, its immense size, its powerful circulatory system, also make it vulnerable in a world it did not evolve to navigate. But perhaps the most insidious threat is one we cannot see at all. Deep within the ocean, subtle changes are unfolding. Temperatures are rising. Currents are shifting. And the tiny creatures that sustain the blue whale, krill, are beginning to move. Krill depend on cold, nutrient-rich waters. As those waters change, so do the swarms. They become less predictable, less concentrated, harder to find. For the blue whale, this is not just an inconvenience. It is a crisis, because its entire feeding strategy depends on abundance, on density, on the ability to engulf thousands of prey in a single lunge. When krill populations decline or disperse, the whale must travel farther, dive deeper, search longer, and with every additional effort, the heart works harder. This creates a dangerous feedback loop. More effort requires more energy. More energy requires more food. But food is becoming harder to find. And so, the whale enters a cycle of increasing strain. A slow, invisible pressure building within its body. The system that evolved for efficiency, now forced into overdrive. Yet despite all of this, the blue whale endures. Across the world's oceans, these giants continue their migrations. Thousands of kilometers, guided by instinct and memory. They navigate a changing world with a physiology that has remained largely unchanged for millions of years. A heart that still beats with the same ancient rhythm. And in that rhythm, scientists are finding new clues. Recent advances in biologging technology have allowed researchers to monitor not just heart rate, but movement, depth, feeding behavior, and environmental conditions all at once. By combining these data, a new picture is emerging, one that reveals just how finely tuned the blue whale truly is. Its heart does not simply respond to activity. It anticipates it. Before a deep dive, the heart begins to slow in preparation. Before a feeding lunge, it accelerates just enough to meet the demand. It is predictive, adaptive, almost strategic. This level of control suggests a degree of physiological intelligence that we are only beginning to comprehend. A coordination between brain, body, and environment that operates on a scale unlike anything else in the animal kingdom. And yet, even this extraordinary system has limits. Because at its core, the blue whale's heart is still bound by the laws of physics. Blood can only move so fast. Tissues can only stretch so far. Oxygen can only diffuse at a certain rate. There is a boundary, a line that cannot be crossed. And as human activity continues to reshape the oceans, the whale is being pushed closer to that line. But here is the most unsettling question of all. What happens if the heart can no longer keep up? If the demands of a changing ocean exceed the capacity of this ancient system? There will be no gradual adjustment, no evolutionary solution in real time. Only failure, a missed beat, a system overwhelmed, a giant brought down, not by predators, not by age, but by the quiet accumulation of pressures it was never designed to withstand. And yet, for now, the heartbeat continues. Slow, powerful, unimaginably precise. Somewhere beneath the waves, a blue whale dives once more. Its heart begins to